Welcome to video T.3B, more on rotations. So here's the technical definition of a rotation. A rotation is a transformation about a point P called the center of rotation such that each point and its image are the same distance from P and all angles with vertex at the center of rotation formed by a point and its image are congruent. Whoa, that's a lot. It won't mean anything until we actually do it. All right, so I've got a few steps down here. Again, they won't mean much until we do it. We're going to measure the angle of rotation initially. I've got that right here. All right, so in this instance, smaller protractors are better than big protractors. So if you've got a big protractor, get rid of it and get a small one. All right. So even with a small one, I had to extend the line. So I've got a overhead shot of the problem. So the problem is to rotate triangle XYZ about point P for the measure of angle A. Okay, so here's triangle XYZ, here's point P, here's angle A. They don't give you the measurement, we've got to do that. So you line up your protractor so that the center dot is at the vertex of that angle. And you line up the protractor such that one ray falls on the 0 or 180 mark. And what I did is I extended the angle such that I could more easily use my protractor. Okay, so again, to measure the angle, we extend the angle so we can more easily use the protractor. Then, notice the protractor has two different numbers on the scale. Okay? So what I say to myself is this angle bigger than 90 or smaller than 90? Well, if it was 90 degrees, I've got a little piece of paper right here. Oh, that's 90 degrees, so it's smaller than 90 degrees. So I want to use the angle numbers on the protractor that are smaller than 90. So I won't be using the 150, 160, I'll be using these. Okay, so 0, 10, 20, 30, 40, 50, 60. And then it's like in between, I found 65, 66, 67, 68. You won't be exact, try to be close within a degree or so. All right, so I measured it to be 68 degrees. Okay, then what? Then next, draw a line from the center point of rotation to a vertex point. So I labeled these X, Y, and Z, so I'll just measure a line as such. Or make a line as such. So everything is referenced from the center point of rotation. All right, then what I want to do is, this is the most critical step right here, this is where all the mistakes are made. Construct an angle congruent to the angle of rotation in the correct direction, counterclockwise, centered at point P. Okay, so I'll just use this other protractor over here. Again, what you want to do is line up the center point of the protractor at point P, and then you want to line up the 0 mark on that little line you made. Then 67, 10, 20, 30, 40, 50, 60, 67 is about there. Then what you want to do is construct a line like such. So all I've done is I've said, hey, that's 68 degrees, of a rotation. Now what I want to do is use a compass or a ruler to measure along this, and I want it to be the same length as that. So I could use a ruler, I could measure that out to be a certain distance and measure that out. But I find it easy to use a compass. So, if you have a compass, just to let you know, lefty-loosey, righty-tighty, and a lock nut. Okay? So what you want to do is put the pointer at P, and what we're going to do is put the pencil mark at X, and I'm just going to rotate like such. And then that's going to be my next point. And I like doing it with a compass because I could clearly see the rotation happening in real time. Okay, so this is x prime. Again, I could have measured it. This distance here is that. This distance here is that. Okay, then I've got to repeat the process for point Y and point Z, and then at the very end connect the dots. Okay, let's give it a try. So what gets confusing here is all the crazy lines. So maybe I'll pick a different color. I'll pick blue. So now what I'm going to do is repeat this process with Y. So everything is referenced from the center of rotation. So now I'm drawing to Y. Now I'm constructing a 68-degree angle with my protractor. So now again I'm using the blue line. I'm going to put the center point at P. Using the blue line, counting out 68 degrees. Got it there. Constructing that angle. And then once again, you can either measure with your ruler or use your compass. I'll use my compass. So from Y, boom, that's the spot right there. And I will call that Y prime. Okay, repeat the process with Z. Let's see, I'm running out of colors. I'll use red as my helper line. So from P to Z. Then, oh, come on. Drop the protractor. Putting the center of the protractor at P along that new red line that we made. That's where students get confused. The zero mark is right there. And then going 68 degrees. 10, 20, 30, 40, 50, 60, 70, 68. Making a helper line there, and then either measuring with a ruler or using a compass. I will use the compass. Again, what I care about is that red line. That will now be Z prime. Okay, so now what I'm going to do is connect all the dots. I'll do it in, I guess I'll do it in black. And I'll just shade them in. And again, it won't be exact, but just try to measure as accurately as possible. Again, the big ticket item is constructing these angles right here and going in the correct direction and reading the protractor properly. So there you have it, the technical definition of a rotation and how to perform a rotation of a triangle about a fixed point.